what will happen is I will not be able to understand what is happening in the background. So will you please unmute yourself and let me ask a question or something that you wanted to understand. Okay, so don't hesitate. So I will share the session now, share the screen. Please let me know if I am audible and also visible. Not my
Yes,
screen,
sir.
I mean.
Okay. Yeah.
So is the screen visible?
Yes, sir.
Great.
Yes, it's visible.
Yes. Okay. Thank you. Thank you. So what I'm doing is I'm making the screen, maximizing it so that most of the portion of the screen is occupied with this screens, PowerPoint screens. Okay. So we are going to start and understand Terraform. It is a DevOps very, very important tool. It is an infrastructure as a code tool. That means it will be fitting into the operations operate group. Remember, in our DevOps sessions, we have seen which tool fits in which phase. Okay, so I will say our Terraform happens in the operate. You divide it into two sections. On the left hand side is developer or development. Operations. So the when you join them, between the development team and the operations team, and operations team consists of testing team, quality team. Okay, so on the right hand side, that is, there is an operate phase, operate part. There you will find three tools. One is Terraform, one is Ansible, and one is Kubernetes. Okay, so these are the very, very important tools. There are other tools as well, but these are very popular. The most popular tools are in this operate phase because they are infra infrastructure tools. So, and the infrastructure you must have remembered, where we have mentioned, is entirely under operations team. The entire infrastructure is owned by whom? By operations team. Like if they want to deployment is one phase also under the operations part. Deployment, under which we will learn Docker. Docker is one of the tool. So Docker is a tool under deployment phase or part, very important tool. And that part that happens under the deployment, I mean the operations part, not on the left hand side, it is on the right hand side. Similarly, for the infrastructure, you want to develop the infrastructure of an organization, like you want to create your development server, test server, pre-production server, and production server. Any number and any composition of a server, like it can be a Windows machine, a development. It can be a Mac machine, Mac OS. This can be Ubuntu Linux, and this can be a Red Hat Linux. So it can be any combination of the operating system. But you are going to use this tool to create and configure. So this is configuration. Management tool, and this is provisioning tool. Can anybody tell me the difference between provisioning tool and configuration tool? You can give a live example as well. So by Terraform, we are trying to create our infrastructure, whether it's a server, whether it is a storage. We can create our storage. We can, like S3 bucket. We are creating an S3 bucket, or we can create our EC2 instance, that is our server. We have learned about all this cloud. So you can see that Terraform is getting used to create some infrastructure over the cloud, isn't it? From outside. You can create database. You can do whatever creation that you need to do. You can do some IAM users. You can create them, or everything is an object that you can create. You can create your key pair. You can create your security group. Okay, you can create your load balancer ELB. You can name it. Whatever you can think of, you can create through Terraform. So that's why it is called provisioning tool. Provisioning means, like say you are building a house. Your house is getting built. Okay. 2-story building. Stair or lift, whatever it is. So you are building the infrastructure. So you are creating a building. You are creating a building. Now, you have created a building with the help of some architectural design, or with your engineers, with your laborers, with the materials that are required for building the infrastructure for the building. Now, that is, if I take it in the IT terms, it is a tool called Terraform that will build your infrastructure. Now, your infrastructure is built, but now you want to make it habitable. You want to make it habitable. That is fine, that it's a nice building, but now you want to come and live inside it, in this floor, in this part, you want to stay. What will you do? Can anybody help me? What is the next step that you need to take to make this flat or the part of the building habitable?
You use the tool as
bed and refrigerator, TVs, amenities, and gadgets.
you use Ansible, the configuration tool to
Yes.
configure. Yeah.
Yes, configuration. So in terms of building, it will be like you will be doing the interior design, isn't it? You will be doing the interior of your flat so that it is habitable. It is nice to, it is very nice to live in. So comes configuration. So you will configure it into the environment according to your adaptability or the environment that you like to work in. So comes Ansible. See, it is very much realistic. You are building a house with the help of Terraform. You are making an interior design and configuration with the help of a tool called Ansible. Think of an organization where you have created your server, your network, everything is working fine. But still, I need to also you have installed, you have created with the server comes the AMI, the operating system and all those things. But you want to now configure users into it, or the users are also created through Terraform, but you want to configure those users, or maybe there you want to install some security patches. You want to install an alarm. So these are part of the environment that for your security, you want to install some database softwares. Okay, you want to install some application software. You want to do all those things. So that means you are building up your environment that has been already created, but in a raw form. Terraform cannot go beyond or do some activities which Ansible can do. To some extent, it can do. Ansible can also do some work which Terraform can also do. So they are very much hand in glove to each other. But Terraform can perform the provisioning work far, far better than Ansible. So if you deploy or if you employ Ansible to do, suppose you are a civil engineer and you have got a job in IT. Will you do justice to your job? Will you be able to do justice to your job? Similarly, the work of Terraform is to build the infrastructure that will not be possible entirely using Ansible. It can do a little bit of provisioning, but not all. Whereas Terraform can do a little bit of configuration, but not all. Are you getting me? So their job is cut out. Okay. And then the Kubernetes. So we will not learn. I mean, we will have an overview of Terraform and Kubernetes. In this cycle, I decided to skip Ansible because I have observed people are not very interested in having an overview of Ansible because maybe it becomes a bit tough. But in our job ready training, we do all these tools because Ansible is a must for learning in details. Okay, but for our internship sessions, we will skip Ansible because it is a bit something that you need to. I cannot cover it within 2 hours or maybe 4 hours maximum. It is quite difficult. But Terraform I can do justice because if I can learn a bit of Terraform, Ansible automatically, when we learn in the main course, Ansible learning will be much easier. So I have skipped this part. We will do, instead of Ansible, we will take another session of Terraform for hands-on. That I thought was much more important than having another session on Ansible. Okay, let us do theory part of Terraform today, and let us do the hands-on the next Saturday. Is it fine? Some demo examples, what we can do. We can see that how Terraform within minutes can do the desired, whatever we desired. Any question so far?
No questions, sir. But wanted to say if you could just do some introduction to Ansible, I think it would be wise. At least we just have an overview in this internship program. Yes.
Okay, no problem. No problem.
Yeah.
No problem. Yes. So what I will do, we will not have a hands-on on Ansible because it will be a bit difficult to straight away go into the hands-on of Ansible, but Terraform I will do. So what I will do, theory of Terraform today. Next day, we will have a hands-on on Terraform. And the following weekend, we will do the Ansible as well, as you have requested. Will that be fine?
Yes, yes.
Uh,
Thank you.
Okay, okay, no problem, no problem. Okay, so let me go to the next screen. So what is Terraform? Terraform, as we have understood just now, that is a provisioning tool. So a tool which is used for building some infrastructure, tool for building, or tool for changing the existing infrastructure and versioning infrastructure safely and efficiently. Of course, efficiently. Terraform is one of the most efficient tools of DevOps discovered till now, till date. Terraform comes from the house of HashiCorp. You may have heard this very important big organization called HashiCorp. There is a language called HashiCorp configuration language, HCL. It is not Hewlett Packard or Hindustan Computers Limited. It is HashiCorp configuration language. Because after all, everything is a configuration. When you come to the operate phase, when you provision it as if you are doing some configuration. It is as simple as that. Infrastructure as a service or infrastructure as a code. So there is a configuration file that you have to execute. You execute with some Terraform commands. Okay. So this configuration is like some HCL, HashiCorp configuration language. It is not a code like a C++ or Java or PHP or Python. It is not like you do not need to know programming language. It is just like a set of or a block of scripts or very simple. When you see the structure, you will know these are simple instructions. You are giving it to Terraform to be executed. To create, it will create. After the execution, it will create an infrastructure. It can be anything. Okay, so Terraform is that tool. When you install and run some Terraform command on this configuration file, it will create some infrastructure on the cloud, on any cloud, any cloud. That is sitting somewhere, anywhere in any corner of the world, you can create your infrastructure on any other part of the world. Isn't it fantastic? You do not need to be in US. You can be in India. So some 36,000 kilometers away. Doesn't matter. You can travel that distance within seconds and create your infrastructure over in an office or over a virtual cloud. Okay. Now, so Terraform can manage existing and popular cloud service providers as well as custom in-house solutions. Okay, like you can deploy or work with Terraform over any cloud, whether it is AWS, Azure, or GCP, Google Cloud. It can be Oracle Cloud, it can be IBM Cloud. There is till date, there are more than 75 cloud providers available. So Terraform can work with any cloud. You mention the cloud that you want to work with, it will do. It will be able to provision the infrastructure over any cloud. configuration file. As I was saying, these are the main files, configuration files. So configuration files describe to Terraform the components needed to run a single application or entire data center or your entire data center. So whether you are putting the infrastructure over a data center or you are putting that infrastructure on a cloud. It can be an in-house, that means in-house means on a data center, or it can be over any cloud, popular cloud. So Terraform generates an execution plan. So execution plan is like you are creating a blueprint. Like any architecture or some engineer, before creating a building, do they start immediately starting with the bricks and the stone chips and the cement and the sand? You start working? No. They will create a blueprint or an architectural design, and then it will be approved or passed by the management. Yes, this particular design is fine for this particular architecture. Similarly, Terraform will also generate an execution plan describing what it will do to reach the desired state and then execute it to build the desired infrastructure. So you create a plan, then you execute the plan to create the infrastructure. So the plan will give you an idea what are the things that you are going to create and in what form. So the configuration file will be executed at the planning stage, and that output file will be applied. So plan and apply. When you apply, so Terraform plan, this is a CLI command, and Terraform apply. Terraform apply. So what will happen is this apply will work on the plan that has been produced in the previous stage. It will apply. That means whenever you apply, you are basically executing the same plan to create the infrastructure. Now this can be, so you have created a building, first floor. Okay, you do the planning again to create the second floor. So first floor has been created, you execute it incrementally to the second floor. Okay, then you extend your building to the third floor. So you do not have to, every time you pass, this is pass 1, 1, 2, 3. You do not have to do it from first floor. This is called incremental changes in the configuration or in the infrastructure. So once this is done, to do the second, you only do the second. That means you bypass this and do it. So incremental, you increment. You do not have to repeat this job because it has already been constructed. Similarly, the configuration changes, the Terraform is able to determine what, so you will make the changes in the single configuration file. You make the changes and the effect will be that whatever is present, whatever has been created or desired will be incrementally applied over the existing. So this is an infrastructure which is existing and you desired to expand on it. Therefore, it is called incremental. When you say from existing to incremental, you do not recreate which is already present. Okay, through incremental configuration, incremental changes. So Terraform is able to determine what changed and create incremental execution plans which can be applied. You plan, you apply. But in between, if there is something which is already existing, it will not touch that. It will go and apply the other changes that has been incrementally applied. So the infrastructure which the Terraform can manage includes low-level components such as compute instances. That means if it is you are working on AWS Cloud, it is EC2 servers. Storage, it can be EBS or S3 or anything for storage. Networking, you can create your own VPC, the availability zones, the subnets, and there are so many networking elements. You can create any one of them, as well as high-level components such as DNS entries. That means which are very high level. These are low level. Low level means low level, which are tangible. And these are, or say hardware. You can say in simple terms as hardware. You are creating the hardware, the low levels, as well as the high level, which are softwares. Software. The high level. Like DNS entries and SaaS features. What is SaaS? Anybody?
Software as a
service. Yes. Like for an example, a mail domain, a mailing domain. It is not a, yes, it is part of the infrastructure, but it's a high level infrastructure, which is mainly a software part. That means you will do a mailing domain with the help of Terraform. So that is a SaaS, software as a service. So it's a service, it's a mailing service, but which is a software. So sending, receiving, deleting, tracking, everything will be taken care by this SaaS features. You can build your SaaS features using Terraform as well. So it is not only the hardware level, low level, it is also the software high level. You can use Terraform for all those purposes. Is that clear? Any question?
How you explain about EC2, something like that said?
Yeah, I said EC2. EC2 is nothing but your Elastic Compute Cloud or Elastic Cloud Compute. It is a part of AWS server. AWS is the cloud. We have discussed that in the previous 2 sessions. So we had also a demo of how to create an EC2 server. We have done using the management console of AWS. You were not there, right?
Yeah. How can I get that record?
Yeah. That is what I said. You will get all the recordings after I have completed. This is sort of a punishment that I'm going to give because earlier we were very very open-hearted and very broad-hearted, and we used to give all this. We had given all the recordings and after each and every session. But what is happening is day by day our population is getting down. So we thought maybe the students are more into. They say, okay, we will go through the video record. Why they taking the trouble to attend the live sessions? So we have stopped giving immediately after the session. What we have planned is after the entire cycle of DevOps, I will give all the recordings for each of the session. Is that fine?
Yeah, that's fine. But in order to attend, currently I have to cover that kind of. Is there a possible way to share me and to?
Okay. So we can be a bit flexible, no issues. So because see, our main purpose is that to help you. It's not that we have to hide anything with you, but only that because we were not getting enough students to attend these sessions. Okay. So what I will do, I will release the previous session recordings as well in the groups. Will that be fine?
Yeah, that will be okay. Thank you very much.
Great, great. So we have already discussed that infrastructure as a code. So it is basically you are doing a code. How? You will say how we are doing a code. It is basically the configuration file is like a code. We are doing a configuration file through some, we will go through some demo in the next session. It is infrastructure as a code, sorry, IaaC, or infrastructure as a service. So it is simple. It is not a code to be very strict. It is some sort of a script, and that script is HCL, HashiCorp configuration language. It is not a programming language. It's a configuration language. Very simple. We will see that. So through this, when you execute this code, what is the program? Program is a group of or a block of code, written in a particular syntax of that language. Okay, so that let's say you are writing a Java code. So you have to follow the syntax and the grammar of the language called Java. And you produce lines after lines of code to help build a product, some features, some functions. Okay, you are building some consisting of features and functions. Okay. Similar thing that you are also doing a program, a code, but that is strictly an IaaC, some scripting language code, the output of which is also some product, and that product is the infrastructure. That is also a product. So that's why you are writing a code to produce an infrastructure. So it is infrastructure as a code when you execute this. Infrastructure is described. So you describe on a very high level configuration syntax, very high level. You do not need to go. Actually, this configuration will be interpreted by Terraform into some very internal changing of into the machine language. Okay, but you do not need to worry about that. You write simple English, straightforward configuration code according to the syntax given by HCL, HashiCorp Corporation HashiCorp configuration language. Like you follow the Java syntax, here you follow the HCL syntax. This allows a blueprint of your data center to be versioned and treated as you would like any other code. Execution plan, like you have to do a plan output. If the planning is correct, then your application, you apply it and execute it to actually give it a shape. This planning does not create any infrastructure. It is just a blueprint, an execution plan. When you execute that plan, then only you apply it and create the actual infrastructure, whether it's S3 bucket or EC2 instance or IAM user. These are all AWS services. Okay, so you do it, but not going inside or not using the AWS console management. Without going into the console management or the graphical AWS console manager, instead of going there inside, because you will not be allowed to get access to the console manager. When you are working in an organization, good organization, they will not allow you to directly work on the cloud console. So how will you create all this infrastructure? You will use Terraform. Okay, we will use Terraform. And there is the automation, and that is the buzzword in this entire industry, IT industry. Everyone is after automation. How well you can do the automation. For this, most of the organizations who have implemented DevOps are using Terraform. So you are trying to automate your infrastructure development. Similarly, you will be using the configuration automation using Ansible. So there can be a very complex chain sets. You are creating hundreds of servers with so many networking and getting worked out and everything. So it can scale up into a complex configuration. So in that case, you still do the configuration, that HCL configuration, that configuration file, but that will be a cluster of files called chain sets. This is a term used in Terraform, chain sets, which when applied to your infrastructure with minimal human interaction, because you are doing the automation, minimal human intervention. So you can create a large infrastructure, a complex infrastructure. So there can be a huge amount of infrastructure, but you can do it simply with an automation using chain sets. These are the things that we learn in details when in our full course. And in our full course, last of all, you will be doing the capstone project. Capstone project is nothing but a project which is an industry standard project. That means when you are appearing for DevOps interview, they will first question is, do you have DevOps experience? You may not have any DevOps experience. Actually, you have not worked in any organization as a DevOps engineer, but still you have to get the job. And since you have done a capstone project, which is exactly what you are going to do in your company, in your organization, you say, yes, I am experienced of 1.5 years by doing simply one good capstone project. That is good enough for an entry. Because here, whatever the tools that you are learning, like you will be using GitHub, you will be using Git for the versioning, you would be using Docker, you would be using Terraform. See, while learning it, you will be learning discretely. That means separately. You will be learning each of the tools separately. But the question is, okay, let me finish. you will be using Ansible, you will be using Kubernetes, you will be using AWS Cloud, and you will be using Linux, shell scripts, shell scripts. You must be very good in Linux. Okay. If you have to do very good in cloud, if you have to do very good in DevOps. Okay, Linux knowledge is good, important. And finally, you would be using CI/CD pipelines. All this thing combined over the pipeline to produce an automation product. You have deployed your application that developed by the developers automatically through the pipeline using in this complex architecture is your capstone project. So in doing one capstone project, you will get an idea how you stitch the various beads. Beads means the various tools of DevOps tools into one garland. Garland means the ornament that you put into your leader's neck when in the airport, when they are visiting your country. So here also all the tools you combine together to produce one product. That means your application, whether it's a Java application or your Python application, or it's a microservices application, including so many, like it can be is a combination of Java, combination of Python, combination of PHP, combination of .NET, but in microservices. So all these applications combined together will be now automatically deployed and changed. Whenever there will be a change in that application, every time you will test, you will deploy, you will do all these things. So over the cloud, over the Kubernetes orchestration, we will learn that. And over the CI/CD pipeline. So the pipeline will work automatically. So everything will be automated. You do not need any manual intervention. So if you have done such a beautiful project called Capstone project, you have a very, very good concept of how DevOps projects are executed in an organization. That's where you create a difference between yourself and another person who doesn't know much at all. You have created a lot of difference. Any question?
So
Terraform features. Yeah.
Are we gonna learn the Git, Docker, and stuff?
Yeah. How we can?
Are we gonna learn the Git and
Docker? Yeah, those are the things that we teach in our normal. This is not a course. This is just an internship session that we conduct every weekend. But actually, we also run our actual course, which is a 2 months course, 5 days per week, each session of 2.5 hours. Okay. So that is almost like 75 hours of integrated program. And out of 75 hours, 75% is hands-on. And 25% is theory. Yes, we need to know theory. But the most important part is we have to do a lot of hands-on. See, if you are intending to work in an IT domain, whether it's a DevOps engineer or a cybersecurity engineer or an AI and data science engineer, whatever it is, you have to be very, very comfortable with hands-on. You are not going to, on the very first day, you will be a DevOps manager. Yes, when you become a DevOps manager, you might not have to work hands-on because you will be having your team of other DevOps engineers where you can guide them. They will do the work hands-on, but that is not possible from the very beginning. You will earn that position once you are good in DevOps. So hands-on is very, very important. So all these tools, Git, first of all, cloud, then Linux, Git, then Terraform, Ansible, Docker, Kubernetes, CI/CD pipeline, that is Azure DevOps. All these things will be taught in much more details with much more examples and hands-on in our main course. Are you getting me?
Yes.
And finally, summed it up with a fantastic. We take generally 4 to 5 sessions of capstone project. I do it myself. The class follows, and after the course, we give a 1 month's time for each of our students to complete the capstone project on their own and submit that project details to us. Then we understand, yes, this person has been able to do it. So he is almost like ready for the interview, for the job. Okay, that is a long history. But let's say, so Terraform features supports multiple platforms, multiple cloud platforms. And there are currently 100+ providers. I said 75+. Actually, it is now more than 100 providers. Providers means cloud providers. Simple configuration language. As I told you, the HCL is a very simple configuration language and faster learning curve. So the curve is not that steep. It is like this. Very simple to learn. Actually, in our main course, I complete Terraform in 5 sessions. Five sessions of 2.5 hours each session. So in 12.5 hours or in 12 hours, we complete the entire Terraform. So can you think, in 12 hours only you learn the entire Terraform with lots of hands-on and practical experience. Because learning Terraform is very fast. Easy integration with configuration management tools like Ansible. So as I told you, Terraform and Ansible go hand in hand. They are like twin brothers. Not twin, they are like brothers or sisters. They work together. They are very fond of each other. Easily extensible with the help of plugins. So it is entirely based on plugins. Plugins do all the talking part of Terraform. So all the code, these are C++ code, the plugins. But you do not need to know anything about C++. That is the beauty of any DevOps tool. You do not need to have any coding experience. You do not need to be a developer. Okay. In our job ready training, what we find is so many people come to us having different backgrounds. Some is coming from accounts background. Some is coming from hospitality industry. Even we have a cab driver as our student, and he is now doing DevOps. He's a DevOps engineer in a big company. So can you imagine this? People coming from various different domains, they do not have much, or rather no experience in IT. No experience, almost nil. From there, because that is one entry point. If you want to get inside IT from any domain, you cannot think of any other entry point other than DevOps. Can anybody tell me why? So think of a cab driver coming to our course, now is working as a DevOps engineer. How? It was because he has taken a very wise decision. I will say, I will appreciate the courage of this guy. Very wise decision to be part of our DevOps course. So what he did is he has entered without any knowledge of programming, without any knowledge of, practically no knowledge of IT. He didn't have any knowledge of cloud or Linux or anything. But still he could cope up because he was serious. He wanted to do something for himself. This guy also, these guys, many students have come from different domains, because this is one area where you do not need to have any language awareness. You do not need to be a coder. If you try to be entering into IT as a developer, the field is saturated. Field is saturated and you will find it stiff. I mean, you have to be an expert, a sort of a genius, to be entering into IT as a developer. Very, very difficult. You can also get inside IT as a tester. But for that also you need to have a bit of good knowledge on IT. You can be also getting entry into with an operations, but operations are very, very specific. You need to have a certain set of skills. But for DevOps, you generally do not need any specific skills. So that is the most wide open entry point to get inside IT, if you are willing to work in the IT domain. Because here most of the tools, these are driven by plugins. Whether you talk about Ansible, you talk about Terraform, most of them are actually driven by inside the programs are all inbuilt. You just have to invoke them through some small scripts. That's all. Any question? Now, some important terminologies on Terraform is you have to write a configuration file, right? That is called the Terraform code. Now, then you put that through the plugins to so there is the Terraform plugin. So using the configuration file and plugins, the plugins will take to the particular, if you are using a Amazon or AWS plugin, you will be able to work Terraform on AWS. If you have plugin of GCP, Google Cloud Platform, GCP, then you will be working specifically on Google Cloud. If you have Microsoft or Azure plugins, Azure plugins. So you are working on the Azure cloud. That means you are working means you are creating all your infrastructure over on the Azure cloud. So similarly, it can be any other cloud. Any other cloud. You use the specific plugin for that particular cloud and you are there. You can provision. You can provision the infrastructure of onto that cloud. You are calling that upstream API. API is the application programming interface. So through the plugins, you call the APIs and APIs will do the job for you for provisioning. But actually, you start with writing simple configuration, Terraform configuration file. That's all. You are doing lots of big things by doing that. So you are doing the Terraform provisioning, like you update, destroy infrastructure resources. So all these are resources, such as physical machines or virtual machines or network switches or containers and many, many more infrastructure. You can update, you can create, you can update, you can destroy also. So configuration are the codes written for Terraform using the human readable HashiCorp language, configuration language called HCL. To describe the desired state. Now this desired state, desired means what you want. What is a very important question for any DevOps guy? You never ask how. Can anybody tell me who will ask how? Who is that person who is always after how? Anyone, any idea? This I am already telling you. This is a question often asked by DevOps guys. But who is asking every time about how this thing has to be done? Or how will this happen? No, DevOps is part of development and part of operations. So basically this how is definitely being asked by the developers. They are more concerned how things have to be done because they are doing the programming. They have to see the logic. You are not concerned with how things are done internally. You are only concerned what is that I want to create. I want to provision. I want to configure. What? What is the question? Whenever you say what, that means you desire what you desire to create. So it is called desired state. Okay. And the providers are the plugins that Terraform use to manage those resources. So as I told you, Terraform works on plugins. Plugins are programs, inbuilt programs that Terraform uses to manage. Manage means what are the attributes of management? When you say manage, I'm managing something. Manage those resources. Resources are the ones that you create as a part of infrastructure. What is you manage? Whenever you say manage, it is CRUD. And what is CRUD? C stands for what?
Create.
Create. Yes, fantastic. And R stands for what?
Read.
Read. U stands for what?
Update.
Very good. And D stands for what?
Delete.
Destroy.
Destroy or delete?
Delete.
See, these are the 4 things that you have to always do to manage. So whenever you say the term, you get the manage term, that means you are doing one of these 4 things. Either you are creating, or you are updating. Updating is changing, or you are deleting, or you are reading, simply reading the resource. Okay. So every supported service or infrastructure platform has a provider that defines which resources are available and performs API calls to manage those resources. So who are the providers? The providers are the platforms on which you are creating your infrastructure, where you are managing your resources. So who are the providers? Can you give me some examples?
AWS. AWS.
Yes. AWS, GCP,
Azure.
Azure, Oracle, IBM, so many clouds. They are the providers. They are your providers. So on which the Terraform will make an API call to manage the resources over this cloud platform. These are platforms. And manage means the CRUD. Terraform will either create or update or delete or read the resources. Is that getting clear, more or less? The function of Terraform? More or less. Just an overview. So by learning this only, you will be able to attend few questions on Terraform in an interview. I'm very sure. At least you can talk a bit, if not all. Yes. So next important part of Terraform is the modules. We will not be able to know the actual purpose or the functions of a module, but it is, if you have some programming background, I'm not saying it is necessary. But if you are coming from a programming background, you will know that actually what they do is, this is a large, one big program solving a problem. Why you write a program? You have been given a case or a problem to solve. Okay, you write some programs in Java or PHP or whatever, and you solve the problem. Now, if the problem is complex or big, better to say big, the bigger the problem is, what you do not write a big program of 1,000 lines. What you do? You break up your program into smaller modules. Isn't it? Module 1, module 2, module 3, module 4. So whenever there is, this module is solving one part of the problem, big problem, one part. Module 2 is solving another part of the big problem. Similarly, module 3 and module 4. So whenever as need basis, you will call either this or this or this or this. You do not need to call the entire, all the modules to solve a particular problem or a part of the problem. Okay. And they can be reusable. So this module you can use for solving another problem which has a part of this problem that can be solved through module 1. And another problem. So there can be n number of problems that can be solved. So you can reuse the module. It's a very important concept. It is like you are doing OOPS, object-oriented programming structure. Okay, so you view each of this as one object. And object, basically the object is a class. Okay, so it is very easy to call a class. So you can have a library of functions. But I am not going to that details because these are all fundamentals to any program developer or a developer. A library can contain lots of functions. Function 1, function 2. They can be separate. They do not have to be dependent on each other. So you can call one library whenever this particular library solves a particular part of a function or a part of a problem. You do not need to call each and everything because they are object. So you will call that particular class if that class is going to solve a particular problem. So similarly, to create a complex architecture or infrastructure, you can divide your configuration file into smaller modules, which are reusable. Reusable Terraform configuration that can be called and configured by other configurations. See, one program or one Terraform is calling Terraform. Let's say you are planning or applying, so you can call this particular module. Another Terraform, which is doing some provisioning, can call this another module, module number 4, because they are already reusable. You have created those modules in such a way. So common configuration. Let's say in a server, there are 4 servers, one in India, one in US, one in South Africa, one in Nigeria. Okay. And you have to call a module. So in India, you have to create an operating system, a server with a configuration of max size of some size with an operating system as Ubuntu Linux. So this configuration is available in module 1, let's say. In US, you have to create a medium level. That means, say, maybe 4 or 16 CPUs. Here you are using 36 CPUs max, big machine. Here you are using 16 CPUs and some amount of memory and all this. So it's a medium thing, and it is using Red Hat. So by calling, so this one I will call module 1 because it helps me solve this problem. Will I be calling module 1 to do this particular thing in US? No, I have created another module which fits in for this configuration. So I will call this configuration. So I will call the module because it's a reusable. And similarly, I can call module 4 over here. And maybe I'm calling module 1. Why? Because in Nigeria, I want the same configuration as I have done in India. Are you getting me now? So why should I call module 3 or module 4 or module 2 for Nigeria when I have already a module 1 which actually caters to the same configuration that I want, that I have implemented in India? So my simple task is to call module 1 to create a similar configuration which is enabled through module 1. Is that concept clear?
Yeah. Yeah.
So if my purpose is solved, if the purpose is not solved, I will create another module and keep it for future use. Module 5. And I can have n number of modules. So this is module n. There is no restriction how many modules you can keep. You, as if it's a pre-programmed, you are putting that into a library and you are calling the library and calling that particular module for solving a common configuration issue, right? Any question? It's a very, very interesting and very, very important concept in Terraform. Many people know Terraform, but in an interview they fail because in an interview, almost invariably you will be asked about modules. And in fact, you will not see any Terraform configuration script without using the concept of module in your industry. Terraform registry is a place where you configure the environment for Terraform to run. So it is using Terraform init. So Terraform will download all the plugins. Basically, I have to write download plugins. Instead of writing everything, it is actually plugins. Off. So if I am trying to do some configuration on AWS, so I have to download the AWS plugins into the Terraform registry. Registry is a repository, you can say. Repository is a storage where you keep all your required files and modules and plugins, etc. Is it clear? To use a provider or module from this registry, just add it to your configuration when you run Terraform init. We will see that. We will see that next weekend. No need to worry about this. Just try to understand the theory part of it right today. So why do we need infrastructure provisioning? Yes, you need. Because if you do not use Terraform, what will happen? You have to use the proprietary. These are all proprietary to each of the cloud. Proprietary means it is owned by. So the cloud formation service is a service that will provision the infrastructure over AWS. This CF service cannot work on Azure. So as if it is owned by proprietary. So if I have to use any provisioning tool on AWS, I cannot use anything but CloudFormation other than CloudFormation. So if you are using Azure Cloud and you want to create your provisioning or infrastructure provisioning, what service you have to use? Can you use CF? No. You have to use Biceps or ARM. It is Azure Resource Manager templates. Either this, they are the same thing. Biceps, better to say Biceps. So will Biceps work on AWS Cloud? Can you use the Bicep service to provision any infrastructure on AWS? Answer is straight away no.
No.
No. Can you use CF to provision the infrastructure over AWS Cloud? The answer is, of course, yes. Similarly, if the cloud infrastructure or the provider is VMware, VMware is from Microsoft also. Microsoft VMware. So So you have to use a configuration provisioning tool called VMware SDK. So that SDK cannot create your infrastructure other than VMware. It cannot work on Azure, no. Cloud, no. SDK can only work on VMware. So is it not proprietary? Like earlier days when you used IBM machines, IBM server, big server. What is the operating system that you cannot use other than that? You cannot use Linux. You could not use HP UX. You have to use AIX. So we say they are tied to each other. So if you are using IBM machine, you cannot use anything other operating system other than AIX. If you are using an HP machine, Hewlett Packard, the big server, then you have to use an HP UX operating system. You cannot use AIX over HP. No. No. Okay. And also no. You cannot use HP UX over AIX. So because they are proprietary, they are OEM. So original equipment manufacturer IBM will only use AIX, which is also original equipment manufacturer from IBM. So this is a great difficulty for any. See, today's organizations are very sort of, they have a hybrid culture. They are not happy with one platform. One company, one big organization or medium-sized organizations can be using multiple cloud. So maybe they are using both AWS and Azure. Few good functions or services from Azure and few important functions of AWS they are using. They are using combination. So for provisioning, will they use CF or Biceps? Nothing. They will not take the services of CF and Biceps. They will use Terraform instead. Because this is one guy who is an all-season guy. Whether you are using Azure, whether you are using VMware or AWS or GCP or Oracle or IBM, doesn't matter. You just have to go for Terraform Enterprise version. That's all. When we learn Terraform, we will learn Terraform open source without paying a single penny. But when you are working in an organization, Terraform, they have organization because they are using for commercial application. So enterprise version. That is the difference. You have to, the company has to go for licensing. Whereas for learning, you do not need to pay any license fee. That's why people can learn DevOps without paying a single cent. So many tools you will learn without paying a single cent. Yes, you have to get that AWS account, but that is also in the free tier for the first 1 year. So that's why people come and learn DevOps because they want to get inside IT. And once you learn it, because Terraform open source and Terraform enterprise has no difference, absolutely no difference. Whatever you can use and execute over an open source is exactly the same. What is the difference? This is only the license. That means legally you can use Terraform to produce a production level applications to deploy production level. So when a company hosts something like Amazon or Flipkart, so they cannot use any open source tools. They have to use Terraform, but using enterprise version. That is fine. Is that portion clear? Why we want? Because we want to automate, because we want to come out of the proprietary. We don't want proprietary. We want to use a tool which can work with everyone without any issue. So only you have to download the plugins for that particular cloud. That's all. And that can be used very, very easily over CI/CD pipelines for automation. We will also learn a CI/CD tool called Azure DevOps. Okay. Any question? Are there any people?
Yeah, no, we are here.
Oh, you are here. Okay.
Yeah.
Yeah. Okay. Though it is less, but it is fine. Ah, sorry. That's good. And so what we are doing is we are towards the end of the session. So we will continue in the next session, but let me use another 15 minutes. Is that fine?
Yes, it's fine.
Yes.
Okay.
Yes, sir.
So yeah, correct. So the workflow is very, very simple. You are a developer. You are not a developer. Sorry, you are a DevOps guy, DevOps engineer. You are creating your config file through what? Through which language? Through the HashiCorp
configuration language.
Yes, configuration language.
HCL.
HashiCorp. Yes, HCL. Very simple script type of thing. And then you use this is Terraform. This is the logo of Terraform. You use this Terraform to use plan or apply or destroy. And initially you start with Terraform init to configure your environment. So these are the few commands, CLI commands: Terraform init, Terraform app plan, Terraform apply, Terraform destroy. We will learn this. We will see this. So when you are having this Terraform installed in your configuration in your server, and you are writing configuration files, execute the configuration file through plan, apply, destroy, init, then you can deploy this, whatever the configuration, the infrastructure over Azure. HashiCorp has its own cloud as well. This is a HashiCorp cloud. Sorry?
Can I ask a question?
Yeah. Ask, please.
Okay. So we are in the Terraform to apply or to destroy or to plan any of the providers, for instance, let's say Azure. So the Azure has its own plugins, right?
Yeah, suppose you are doing on Azure, so you have to have there is a thing called Terraform init, so you will take the Azure plugins. So you have to put something into the configuration file which will be executed, and through Terraform init, and there you will mention the plugins for which provider you want. We will see that.
Where do we get those plugins?
That is what we will mention in the configuration file. And when we execute it through Terraform init, so the command is Terraform init. That means we are letting the environment know that we want to download few plugins for that particular cloud provider. Okay, now in that configuration file itself, actually your Terraform init is actually going to work on this particular configuration file. There is a provider, so you can name it anything, but let's say for convenience purpose, .tf. Provider is just the name, and TF is the Terraform file, TF. So whenever Terraform will find this particular file, okay, it will execute this with the command init. So it will initialize it. So initialize means it will download from the cloud, from somewhere. It will download the plugins. Say, let's say you have said AWS plugins inside this. So it will download the AWS provider files as plugins into a particular folder. We will see that. Are you getting me? So that means you have prepared your Terraform environment to work on, let's say, there is no AWS. So let's say Azure, on the Azure cloud. This is GCP. This is VMware. This is HashiCorp cloud. HashiCorp has its own cloud as well. This is Hyper-V. And this is OpenShift. So these are platforms, providers, sort of a cloud provider, virtual provider. Okay, so now they will accept, or the plugins will be downloaded, and therefore you have prepared your environment over to work on that particular cloud. Terraform is cloud agnostic. What do you mean by cloud agnostic?
Can be used on different clouds, on Azure, AWS. I said it can be used on different clouds, on different platforms.
Yes. Yeah. So it is not, if I had said cloud affinity, that means it will be specific to a cloud. But when I say cloud agnostic, it is not specific to any cloud. It is not attached to any cloud. It can be any cloud. So cloud affinity is just the opposite antonym. You know, synonym and antonym in English language. Anyway, so this is just the opposite. Cloud affinity and cloud agnostic. So I do not need to depend. Terraform does not depend on any cloud. You just have to download the specific plugin, because it can deploy to any cloud or virtual infra provider. Terraform integrates with clouds via provider, via plugins. So the config, and then you use the Terraform to be either on Azure or AWS or any other cloud. I think this part is very, very clear. And today, I will end my topic after I have this slide, after this slide. Will that be fine?
Yes.
So the question, okay. Yes. So the question is procedural versus imperative versus declarative. So procedural or imperative is the same thing. Who will do the procedural or imperative sort of thinking? It is the developers. They are because they are onto how things should be done. Whereas this will be you, DevOps guy. DevOps engineer will always think about declarative. I will declare, I will desire what I want. What I want. It's a huge difference when you say what against how. So whenever you say how, that means you are thinking procedural. You are thinking imperative. That means in a structure, you are thinking of a structure. And that structure is provided by some programming language. Whereas whenever you are saying declarative or what, you say some script. Scripts are not languages. So you write some configuration that you want. Small scripts in the same file. Block of scripts. And these are meant when you actually try to do some automation. So a person who has joined new as a developer or a fresher will be always concerned, and it will only asking the lead about how it has to be done. Whereas as an experienced professional who is a DevOps guy will always concentrate on what has to be done. What is the work that has to be done? You tell me what needs to be done. I have tools, I have DevOps tools which can easily do it. Whereas they have to take a long time, create a long, big code to achieve what I can achieve within a day, within an hour. They will be writing for a few weeks to develop that same thing. So which one? See, everything is agile now. Everything is agile. I cannot devote so much of time in designing and thinking about how to get everything integrated and working in an automation manner. I have to deploy it fast. I have to be just in time in the market. Just in time. I do not have a luxury of 1 year. Because 1 year is a big time to be in the market. I have to be in the market within 2 weeks. I will follow an agile methodology. So I will be following DevOps methodology. I will be following declarative way of doing things rather than procedural. So when you are thinking of automation, think of declarative. Using Terraform, we would use a declarative approach. See, a declarative approach to specify what our infrastructure needs are. This is famously known as infrastructure as a code. So the rest of the slides we will do it the next day, and we will do a small demo. Will that be fine?
Yes, Mr. Debasis, that will be fine.
Okay. So thank you. We will end the session today. It was, I don't know how much you have been benefited from this discussion, but I think when we see the next day some examples, some short demo, you will understand the importance. Thank you. You will understand the importance of what we have discussed today. So we will see that in the next weekend. So far, this much till today. I will end the session today. I will stop my recording. Thank you.
Thank you, sir.
Thank you so much, sir.
Thank you very
Thank
much.
you so much.
Thank you.
Thank you, Debasis.
Yes, thank you very much. Have a nice weekend.
Mr. Debasis, thank you.
Okay, thank you. Hello, Shubhro, acho? Hello, Shubhro. Hello. 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 Hello, Shubhro. Okay. I'm Virolam Tale. controller manager through the two-way the help of Kubectl. It's down. All this is quickly replaced. You have a saying that you have three replicas for the same over two worker nodes. So maybe they are not they are having the same application. They are replicas. So once the pods get down, what will happen is all this pod is down because my three in number. That means on my I have deployed with the intention that there will be always three pods of that application available or replica. So a replica set when you have declared or deployed as three will always remain three. If there is a drop of one of the pods, what will happen? How the flow is managed, that we have already discussed. I don't think we should be discussing it again because we have already done that in our previous video. So let us go to the next slide. It is the same architectural view. Are you able to see the screen?
Yes.
I mean, no, will it help if I make it bigger? The full screen? Let me do that. Does it help? Right? So we can have a bigger view. So in this, what we are trying to understand is like this is our, what is this? This portion. What about this portion? This is the control node or the master node, right? Control plane, where you have the API server, HCD, controller manager, scheduler. These are the four main components of the master server, of the master node. And there is a component called kubectl that will also come under installation. Kubectl is the CLI. You know CLI, right? CLI is the command line interface. So you must writing some making some management these are called CTL. I just somebody says or you can say kubectl. Kubectl is a the part of Kubernetes which helps you to interact with the worker nodes. Are you getting me? See, whatever instructions is, you cannot leave it directly over the node 1 or node 2 or node 3 or node 4. Any worker node will not respond to that stream. In kubectl, we only request query of the API server. You give your, see, everything will come to API server. That is the app. This API server will decide whether I need to get some information from HCD because HCD is the database which stores all the information scattered all over the nodes or in the stack with RAM. Or I need to some pod is down, so API server needs to go there and or want to deploy one more application with 3 replica sets or 5 replica sets or 10 replica sets. What you need to do? You will take the help of our API server to the kubectl will deploy basically write a deployment file. We are going to discuss that. A manifest file is executed and that manifest file is on process when it's one file. And with that deployment, you're not going to deploy the pod for the so API server will distribute that manifest file to the scheduler and the controller manager and execute to deploy the files. So see, all the instructions are coming from the instruction. So with API server will do the input after that. Whereas, again, in application that wants to happen with the tool, worker nodes and the trade should also happen with API server. Anything will go out of the API server and anything will come from the interface. Yes, you can say that the controller manager between the worker nodes and the interface. Yes, because everything coming in. But everything will depend on the API server doing tasks, other components there. Between the users and like this. This is why like why is the load balancer can somebody that is a concept of why is the load balancer yeah, it's for architecture like very very poor that is actually but as your application will lots and lots of microservices applications are implemented in or deployed for the disease architecture itself. That's check. And also the okay, they will be using right people documentations scattered by the singular cluster. So they would be what the load balancer is to distribute the loads between because if you don't have a load balancer, you cannot direct or store the load. All over the cluster. So the load balancer has a process. It has an answer. It knows how to find out where it should distribute the or redirect the packets. So generally that happens on the usefulness of load balancer is you determine which node or which core to take that. That intelligence so you may implement a load balancer, but that load balancer can come from the EKS or AKS. Those are cloud provided load balancer. Or you may implement your own load balancer and we are going to learn this thing. At least have a clear that load balancer that ingress Nginx controller. We are instead of because these load balancers that are provided by the to avoid that most of the I have how to implement an ingress controller instead of a ingress controller. Whereas a load balancer can cost a lot of money. So as a person who will be selected, who can save some money for the company, and you are then you this is where now? Sorry for that disturbance. Just give me 1 minute. I will rest. Sorry. So you see, this is a single. So it can be any provider API, that API, which one is said that is being talked to with the cloud, the manager. You business that. So sometimes you may go for the native implementation of the architecture, or taking a help from the cloud provider like Amazon. So what is that called? It's called EKS. Or Azure, it's called Azure. That is a standard implementation of the cloud, which takes major parts. You do not need to implement it. You do not have to administer it. Administration, management, everything. But then it has to interact with the customer. Unheard of. LCD, controller manager, scheduler. You have cloud. You have an EKS or things. Switch will interact. Controller manager, which is this controller manager. Yeah, proxy will be there because it is after all there. And also you will see that you get